Hello and welcome to this video on multiplying matrices. And what we're going to do today is we're going to talk about how we multiply matrices and what we use matrix multiplication for. So what we'll start with is we'll start with the PowerPoint on how to multiply matrices. So we've added them, we've subtracted them. And now we're going to get into multiplying them. So, when multiplying matrices, you must take the rows of the first matrix and multiply it by the columns of the second matrix. And not all matrices can be multiplied together. We can only multiply matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. So let's take a look at this matrix right here. The first matrix is a 2 by 3 matrix. The second matrix is a 3 by 2 matrix. And I'm not sure why it's not showing up, but this should be -3. So if you want to write that as -3, that would be good. And this should be -8. I apologize for that not showing up. And this should be -3 as well. For some reason when I made this PowerPoint to you, the negative values didn't show up. So again, -3 here, -8 there, and -3 there. But anyway, the point of this whole thing is that the first matrix here is a 2 by 3. And the second matrix is a 3 by 2. And together, we can multiply them together because the number of columns in this matrix is equal to the number of rows in this matrix. And that's important. And you'll notice down here, the number of columns of the first matrix is the second number when representing its dimensions. It's a 2 by 3. And the number of rows is the first number of the second matrix. And as long as these two things match up, then we can multiply them because the number of columns of the first has to equal the number of the rows of the second. And then your answer is actually going to be the outside numbers. The answered matrix is going to be 2 by 2 in this particular case. Okay, so that's going to be important. Make sure you have that written down. So let's do an example. And unfortunately, my negative numbers aren't showing up here either. But that's okay, we can make do. This should be -1. So write that in as -1. And this should be -9. And this should be -6. Okay, -1, -9, and -6. I'll have to remake this next time. Alright, but anyway, we have a matrix here, a 2 by 2, 2 rows, 2 columns, and a 2 by 3 for this matrix, and we want to multiply them together. So, in order to do this, we first have to see, does the number of columns of the first one match up with the number of rows with the second one? There are 2 columns here, there are 2 rows here, and so that tells us that we can multiply these because the number of columns is equal to the number of rows. And here's how we do it. So we take the columns of the first matrix, or the rows of the first matrix, and multiply it by the columns of the second matrix. So our first answer is going to be, if it comes up, 2 times 3 plus 1 times 5. Okay, so what we're going to do is we're going to take the first number in the first row and multiply it by the first number in the first column, and add it to the second number in the first row times the second number in the first column. So again, we're multiplying the rows by the columns and adding the result together. And that's going to be the first number in your answer matrix. What we're going to do next is we're going to now multiply the first row again, but now to the second column of the second matrix. And again, we'll do 2 times 9 and 1 times 7. And obviously it's 2 times and -1 and -9, but then we add those values together. So 2 times -9 and -1 times 7. And we'll add them together. And then to finish off the first row, we're going to multiply the first row by the third column. And so 2 times 1, or 2 times 2, and -1 times -6. And add those values together. And what that does is that finishes off the first row of our answer matrix. And remember, what we did is we multiplied this first row by each of the 3 columns individually, and that's how we got our 3 answers in our first row. Now what we're going to do is we're going to take our second row and we're going to multiply it to all the columns of the second matrix. So we'll do 3 times 3 and 4 times 5, add them together. We'll move over to the second column, 3 times 9 and 4 times 7, and add them together. -9, sorry. Move over to the third column, and we'll do 3 times 2 and 4 times -6, and add them together. Once we simplify, we get our answer of 1. This is a -25, 10, 29, 1, and -18. Okay, so let's review really quick. We took a 2 by 2, multiplied it by a 2 by 3, and ended up with a 2 by 3. Because if this is 2 by 2, and this is 2 by 3, we take the first number in the dimensions of this one, which is 2, and the last numbers in the dimensions of this one, which is 3, and we get our answer dimensions of 2 by 3. So there's our first example of multiplying matrices. Let's see if we can do another. Now, if you'd like to do this on your own, feel free. Thankfully, the negative numbers showed up in this one. But when we multiply this, we look at the dimensions. So the dimensions of this one are 2 by 3 and 2 by 2. So the number of columns in this one is 3, and the number of rows in this one is 2. Right away, you should see that the number of columns and the number of rows don't match up, which means we cannot multiply these things together. So there is no solution for this. And we talked about it at the beginning. Sometimes there is going to be no solution for multiplying matrices together. All right, the number of columns of the first has to equal the number of rows of the second. Let's look at this one. All right, so if you think about the dimensions of this one, this is 3 by 3, and this is 3 by 1. So 3 by 3 and 3 by 1. The number of columns in this one is 3. The number of rows in this one is 3. So we're all good. So we're going to multiply these two matrices on the left together and see what it gives us. So we're going to take the rows of the first and multiply it by the columns of the second. And since there's only one column in the second, it should be fairly easy. So we'll do 1 times x, 2 times y, and -1 times z. And we get x plus 2y minus z. We're going to move down to the second row and multiply it to the column, and we'll get x plus 3y plus or minus 2z. It looks like I'm missing another minus sign. It should be minus 2. And then finally my third row times the column, 2x plus 6y plus z. And those are going to equal the 1, the 7, and the 8 on the other side. Okay, because really this is a 1 or a 3 by 1 matrix over here, and this is a 3 by 1 matrix over here. So as you can see, we can use matrices to represent a system of equations. All right, and we solved many of these systems of equations in 3.4 and in 3.2. So now we're going to see how they're helpful with matrices. But before we do that, let's multiply this last example together. All right, so we'll look at the dimensions of these two. The first one's 2 by 2, the second one's 2 by 2. Because these inside numbers match up, the number of columns is equal to the number of rows, we are able to multiply them. And our answer matrix is going to be the outside numbers. It's going to be 2 by 2. So this is able to be multiplied, and the answer should be a 2 by 2. So what we're going to do is take the rows of the first one and multiply it by the columns of the second one. So 0 times 4 and -1 times -2, and we'll add those together. Move over to the second column, 0 times -3 and -1 times 5, and we'll add those together. And then we're going to take the second row and multiply it by the columns of the second matrix. So 1 times 4 and 0 times -2. And then we'll move over and multiply the second row times the second column. 1 times -3 and 0 times 5. And when you simplify that out, you get 2, -5, 4, -3. And that would be your answer for this particular matrix multiplication. All right, let's see what it's actually useful for. Cost of hockey. 2 hockey teams submit equipment lists for the season as follows. The women's teams need 14 sticks, 30 pucks, 18 uniforms, and the men's team needs 16 sticks, 25 pucks, and 20 uniforms. Each stick costs $60, each puck costs $2, and each uniform costs $35. Use matrix multiplication to find the cost for each team. So what we're going to do is we're going to set up a couple matrices here. If you need to, pause the video and write these down, but I'm going to move on to the next slide here. So we can set up a matrix for the women's team and the men's team and how many sticks, pucks, and uniforms they need. We can also set up a matrix for the cost of sticks, pucks, and uniforms. And so what we're going to do is we're going to take these two matrices and we're going to multiply them together. And this multiplication process will tell us how much it costs for each team, for the women's team and the men's team. So we're going to take the women's row and multiply it by the cost. So 14 times 60. Okay, 14 times 60, 30 times 2, 18 times 35, and add all those up. Then we're going to do the same for the men's. We're going to do 16 times 60, 25 times 2, 20 times 35, and add all those up. And when we simplify them, we have our answer matrix with women's costing $1,530 and men's costing $1,710. And so this is nice because we have all this information displayed to us in matrix form, and we can actually use matrix multiplication for something useful. All right, we set up a cost equation, we set up the total amount equation, multiply the two together, and we get the total cost for each team. Notice the rows of this one were women's and men's, and the columns of this one is cost. And that was actually the rows and the columns of our answer matrix. If you notice the columns of this one, sticks, pucks, and uniforms, and the rows of this one, sticks, pucks, and uniforms, those match up. And that's sort of what we're going to be doing. Remember we talked about in order to multiply, the number of columns of the first matrix has to equal the number of rows of the second matrix. Well, when you do it in terms of a story problem, the number of columns of the first should be the same labels as the number of rows of the second, because that's what we want to match up. And see what we're really multiplying, we're multiplying 14 times 60, because there are 14 sticks and they cost $60. We're multiplying 30 by 2, because there are 30 pucks and they cost $2. Multiplying 18 by 35, because there are 18 uniforms and they cost $35. And so that's why the number of columns of the first one has to match up the number of rows of the second one. And that's really it. So that's matrix multiplication in a nutshell. Hopefully that helped you understand how to multiply matrices. We'll have one more video that goes through a few more examples, and we'll talk about the example that we talked about in class earlier with toy cars and toy trucks. Have a fantastic evening.